Hello, science fans. Earthquakes are terrifying. And with recent events, people are more worried than ever. How can they not be? Just last February 6, 2023, 20,000 people died in Turkey and in Syria because of a magnitude 7.8 earthquake. And this was less than a year after the June 22, 2022 magnitude 6.1 earthquake in Afghanistan that killed more than 1,100 people. There was also Haiti in August 14, 2021, where a magnitude 7.2 earthquake killed more than 2,200 people. And that's just in the past 3 years. And when people start talking about earthquakes, they also keep mentioning the big one. The term, the big one, refers to a possible future earthquake of a very large magnitude. And when a region experiences a series of smaller earthquakes, it is often seen as a warning sign that a larger earthquake could occur in the future. The potential impact of the big one and the lack of trust in the level of preparedness and response capabilities of the affected regions are what makes it scary. Imagine, in areas with high population densities, such as cities, the big one could destroy buildings and transportation systems, which could lead to loss of life. This is why earthquake preparedness is crucial in areas where the risk of earthquakes is high. But why do earthquakes happen? And what can we do to prepare for it? Before we answer that question using science, hello to our new viewers. My name is Chona and I'm your resident Filipina scientist. I'm a researcher who has studied environments in mountains and in oceans. I'm also a teacher in the field of biology and environmental science, and I'm very much curious as to how the changes in the environment could affect our way of life. And SHE-ensya is my science communication channel, where I talk about the science behind many things, including the ones that scare us. So, let's talk about earthquakes. Earthquakes are natural phenomena that occur when energy is released from within the Earth's crust, causing shaking or vibrations of the ground. These vibrations can vary in intensity and can cause damage to any structures on the surface of the planet. The primary cause of earthquakes is the movement of tectonic plates, which are massive slabs of rock that make up the Earth's surface. Tectonic plates move due to the heat generated by the core and the mantle of the planet, causing them to shift and smash into each other. When two plates collide, one may slide under the other, creating a subduction zone. And so, subduction zones are areas where two tectonic plates meet, where one can slide beneath the other and sink into the mantle. This process can lead to the formation of volcanic arcs and the creation of deep ocean trenches. The movement of plates at these zones can cause a lot of stress to build up, and this can be released in the form of earthquakes. Earthquakes can also be caused by volcanic activity. One way is when magma moves beneath the Earth's surface, causing rocks to shift and crack, which can then lead to an earthquake. These earthquakes can be a warning sign of an impending volcanic eruption and can provide valuable information for monitoring and predicting volcanic activity. But did you know that not all earthquakes are natural?
What?
Some, small ones, can actually be caused by human activity. Human activities can cause earthquakes through a process known as induced seismicity. This occurs when human activities such as mining or drilling or even the creation of large reservoirs create changes in subsurface pressures or stress fields, which can then lead to earthquakes. Human-induced earthquakes can vary in size and intensity, from small tremors that are barely perceptible to larger earthquakes that can cause damage to buildings and infrastructure. Earthquakes can also be differentiated based on their origin below the Earth's surface. We can have shallow earthquakes that occur at a depth of less than 70 kilometers below the Earth's surface. These are usually associated with the movement of tectonic plates at or very near the Earth's surface, and these can be very scary because they cause a lot of damage. There are also intermediate earthquakes that occur at a depth between 70 and 300 kilometers below the Earth's surface. They are typically associated with the subduction of oceanic plates with continental plates, and they can cause moderate to strong shaking. And then there are deep earthquakes, with origins at a depth greater than 300 kilometers below the Earth's surface. These are usually associated with the movement of tectonic plates in existing subduction zones, and they usually cause less intense shaking because of the depth at which they occur. However, they can still cause damage and can actually be felt over a wider area. When earthquakes happen, they are often described using their magnitude and intensity. But how do we measure these characteristics? Earthquakes are measured using instruments called seismometers, which record the vibrations or seismic waves produced by the earthquake. The data recorded by seismometers is used to determine its magnitude, which is the amount of energy released whenever an earthquake happens. There are several scales used to measure the magnitude of an earthquake, which includes the Richter scale. This scale is based on the amplitude of the largest seismic wave recorded by a seismometer and is the most well-known scale for measuring earthquake magnitude. The moment magnitude scale. This scale takes into account the amount of energy released by the earthquake and is considered a more accurate measure of earthquake magnitude for larger earthquakes. Modified Mercalli Intensity Scale. This scale measures the intensity of shaking and damage caused by an earthquake at a specific location and is used to determine the earthquake's effects on the surrounding area. Seismologists, or scientists who study earthquakes, also use the data from seismometers to determine the epicenter of the earthquake, which is the point on the Earth's surface that is directly above the origin of the earthquake. Earthquakes are natural features of our planet, which means they cannot be avoided. But this doesn't mean that our situation is hopeless. There are ways for us to prepare for an earthquake and lessen its negative impacts. In order to lessen the casualties of earthquakes, governments should develop and enforce building codes. Building codes that incorporate earthquake-resistant design features can help ensure that buildings and infrastructure can withstand seismic activity. And older buildings which do not meet modern standards can be retrofitted with structural upgrades to make them more earthquake resistant. Governments should also develop emergency response plans that include procedures for evacuating and providing medical assistance to those affected by earthquakes, and to make sure to communicate this regularly to the communities they serve. Early warning systems that provide advance warning of impending earthquakes can help individuals and communities prepare better. But can we already predict when an earthquake is coming? While scientists have made significant progress in understanding the mechanisms that cause earthquakes, they have not yet developed a reliable method for predicting them with precision. One of the main challenges in predicting earthquakes is the fact that they originate deep within the Earth and are often caused by complex and dynamic geological processes. The stresses and strains that build up in the Earth's crust over time are also influenced by a wide range of factors, including tectonic plate movements, the composition of the underlying rock, and the presence of fluids such as water and magma. These factors can change rapidly and unpredictably, making it difficult to predict when and where earthquakes will occur. And while earthquakes are scary and dangerous, they play an important role in shaping the Earth's surface and influencing geological processes. The movements that lead to earthquakes create new landforms, such as mountains and ocean basins, and drive the formation of new geological features over time. Some types of earthquakes can also generate valuable mineral deposits, such as gold or copper. Understanding the geological processes that lead to these deposits can help inform mining practices and contribute to the development of new mineral resources. But what do you think? What tips can you give to the rest of our audience when it comes to earthquake preparedness? Are you also interested in learning about how the Earth changes all the time? Let us know your thoughts in the comments section below.